Have you ever made a choice and wondered what would have happened if you'd chosen differently? What if you took that job in another city? What if you had said yes to that date? According to some of the wildest theories in modern physics, every one of those alternate paths might actually be happening right now in universes parallel to our own. This isn't just science fiction anymore. It's an idea that some of the brightest minds on the planet are seriously considering. Today, we're diving deep into the mind-bending science of parallel universes. So, where does this crazy idea come from? It's not just one theory, but several, all branching from different areas of physics. Let us start with the one you've probably heard about the most. The many worlds interpretation of quantum mechanics. To understand this, we need to talk about the weirdness of the quantum world. On the tiniest scales, particles like electrons don't have a definite location until we measure them. Before that, they exist in a superposition, a fuzzy cloud of all possible locations at once. It's like a spinning coin. It's neither heads nor tails, but a mix of both until it lands and you look at it. The act of measurement collapses this cloud of possibilities into a single, definite outcome. But in the 1950s, a physicist named Hugh Everett came up with a radical alternative. He asked, what if the cloud of possibilities never collapses? What if, instead, every single possible outcome actually happens? According to Everett's many worlds interpretation, when you make a measurement or a choice, the universe splits. One universe is created for each possible outcome. So, when that quantum particle could be here or there, the universe splits in two. In one universe, you find it here. In the other, a copy of you finds it there. This branching happens constantly for every quantum event. This means there's a universe where you wore a different shirt this morning. A universe where dinosaurs never went extinct. And a universe where you are a celebrated astronaut. Every possibility, no matter how remote, is realized in its own separate reality. It's a staggering thought, an infinite tree of branching timelines, each one as real as our own. No special status for our universe. We're just one leaf on an unimaginably vast cosmic tree. Now, if the many worlds idea sounds a bit too much, let's look at another path to parallel universes. One that comes from our understanding of the cosmos itself, the theory of eternal inflation. We know our universe began with the Big Bang and then went through a period of incredibly rapid expansion called inflation. This smoothed out the universe and set the stage for the galaxies and stars we see today. The theory of eternal inflation suggests that this process might not have been a one-time event. Instead, picture the universe as a giant, bubbling pot of cosmic energy. Our universe is just one bubble that popped into existence when a small patch of this cosmic soup stopped inflating and cooled down. But elsewhere in this cosmic pot, inflation is still happening, and it will continue to happen forever, constantly spawning new bubble universes. Each of these bubbles could have its own Big Bang, its own set of physical laws, and its own unique properties. Some might be similar to ours, while others could be so alien we can't even imagine them. In this multiverse, our universe is just one island in an infinite cosmic ocean of other islands, each separated by an ever-expanding space that we can never cross. This isn't just a random guess. This idea is a natural consequence of the same inflationary models that so successfully explain the data we've collected about our own universe from things like the cosmic microwave background radiation. So, the evidence that supports our own cosmic history also points towards the existence of countless others. Let's travel to another fascinating realm of physics, string theory. String theory is one of the leading candidates for a theory of everything, a single framework that can unite quantum mechanics and Einstein's theory of general relativity. The core idea is that the fundamental building blocks of reality aren't point-like particles, but tiny, vibrating, one-dimensional strings of energy. Different vibrations of these strings give rise to all the different particles we see, like electrons and photons. Think of it like a guitar string. Plucking it in different ways produces different musical notes. In the same way, these cosmic strings vibrating in different ways produce different particles. Here's where it gets really interesting. For the math of string theory to work, it requires more than the 3 dimensions of space and 1 of time that we're familiar with. It needs at least 10 dimensions. So where are these extra dimensions? The theory suggests they are curled up or compactified into incredibly tiny shapes, too small for us to perceive directly. Now, imagine these extra dimensions can be folded up in a huge number of different ways. Estimates suggest there could be 10 to the power of 500 possible configurations. Each unique way of folding these dimensions would create a different vacuum, a different universe with its own set of physical constants and laws. This vast array of possible universes is often called the string theory landscape. In this landscape, our universe is just one valley with a specific set of laws that happen to allow for stars, planets, and life to form. Other valleys would represent other universes. Some perhaps barren and empty, others potentially teeming with forms of existence we can't even begin to comprehend. So, we have at least 3 different paths from mainstream physics pointing to the possibility of parallel universes. Quantum mechanics, cosmic inflation, and string theory. But this leads to the biggest question of all. Can we ever prove it? Can we find any evidence? This is the ultimate challenge. By their very nature, these other universes are separate from our own. Interacting with them or even observing them seems impossible. Many worlds branch off and never reconnect. Bubble universes are separated by expanding space we can't traverse. However, some scientists are looking for subtle, indirect clues. For example, if our bubble universe ever collided with another bubble in the distant past, it might have left a cosmic bruise, a specific pattern or anomaly in the cosmic microwave background radiation, the leftover heat from the Big Bang. Scientists have searched for such a signature. And while some tantalizing spots have been found, there's no conclusive evidence yet. Another mind-bending possibility comes from quantum mechanics. Some have suggested that if we could build a powerful enough quantum computer, we might be able to harness the processing power of parallel universes to perform calculations impossible in our universe alone. The very act of a quantum computer solving a problem might be evidence of it interacting with its parallel selves. This is highly speculative, but it's an active area of theoretical research. Even without direct proof, the idea of the multiverse helps us tackle some deep philosophical questions. One of these is the fine-tuning problem. Why do the fundamental constants of our universe, like the strength of gravity or the mass of an electron, have the exact values needed for life to exist? If they were even slightly different, stars wouldn't form, chemistry would be impossible, and we wouldn't be here to wonder about it. One explanation is pure luck. We just won the cosmic lottery. But the multiverse offers another answer. The anthropic principle. If there are countless universes, each with a random set of physical laws, it's not surprising that at least one of them, ours, would happen to have the right conditions for life. We exist here because this is one of the few universes where we could exist. It's like asking why we find ourselves on a life-bearing planet. We don't live on Jupiter or Mars because we can't. We evolved on Earth because it has the right conditions. The multiverse applies this same logic to the universe itself. The science of parallel universes pushes the boundaries of our imagination and our understanding of reality. It challenges us to accept that our familiar world might be just a tiny fragment of a much larger, more complex, and far stranger cosmos. Whether it's the branching realities of quantum mechanics, the bubble universes of eternal inflation, or the vibrational landscapes of string theory. The idea that we are not alone is no longer just for fiction. It's a serious possibility emerging from the deepest and most successful theories of modern physics. We may never get to visit these other worlds, but just knowing they might exist changes everything. It adds a profound sense of wonder to our place in the cosmos. What do you think? Which theory seems most plausible to you? Let me know your thoughts in the comments below. Thanks for joining me on this journey to the edge of reality. If you enjoyed this video and want to explore more mind-blowing science, make sure to like, subscribe, and hit that notification bell so you don't miss our next adventure.